Assalamu alaikum guys, welcome back to e-learning. Today we will discuss some discrete random variables, some probability distributions of discrete random variables. If you recall last time in last two lectures I went through in detail about discrete random variables and its probability distributions. We gave some examples and we also introduced the mean and standard deviation of probability distributions, bar charts and stuff like that. So there are some special well-known probability distributions which are related to the discrete random variable. So we will discuss binomial and multinomial distributions today. There are other discrete random probability distributions as well. In next lecture I will go through another distribution, but in this lecture today we will discuss about binomial and multinomial distributions. So let's discuss in detail what are binomial distributions. So first of all, as you might have noticed that we often concerned with repetition of experiments. For example, we repeat a coin tossing, let's say 3 times, 4 times, 10 times, right? We can repeat this random experiment of a tossing a coin. If I do it 10 times, then each time a toss of a coin will be called a trial. Okay, we call it a trial. Let's say one random experiment consists of 10 tossing of a coin, then one toss of a coin will be called one trial. All right. So we are interested in experiments, rather each trial of an experiment, right? So see, trial is repeated a certain number of times to make it an experiment, all right? Now we are interested in those experiments which have only two possible outcomes. So your one trial has two possible outcomes. That's why we call it binomial. You see, bi is for two, right? Bi is for two. So each trial of an experiment has only two possible outcomes. So for example, if I toss a coin, right, then each toss is a trial and there are only two possible outcomes, which are head and tail. So see, head and tail are two possible outcomes. So I can say that tossing of a coin is concerned with the binomial distribution. Testing the performance of a processor. You know, there are in computer language we only consider these binary numbers 0 and 1, right? So only two possible outcomes are either it will be 0 or 1. Weekly sales of a car salesperson. The salesperson has several customers during the week, which are the trials. Now a customer will either buy a car or he will refuse to buy a car, right? Either he will buy or he will not buy. So see, again, two possible outcomes. So these experiments who have just two outcomes are called Bernoulli trials. Bernoulli trials, because Bernoulli is the one who introduced these experiments, this distribution. Binomial distribution was given by Bernoulli. So he called that trial a Bernoulli trial. I think you heard this name in differential equation as well. We studied Bernoulli differential equation, right? So this is the same Bernoulli. Let X denote the number of successes in n Bernoulli trials, you see. So I am interested in n trials. Okay, n can be any finite number. It can be 10, it can be 5, it can be 20. All right. Now every trial has either success or failure, right? Now success or failure can be anything. Let's say in tossing of a coin, I can say head is my success, then tail will be failure, right? And now I know that what is the probability of success in coins? Probability of head is 1 by 2. So that P will be 1 by 2. So I'm interested in two things. One is how many trials you are doing, and in one trial what is the probability of success. So n and p will be given to you in a binomial distribution. Then the probability distribution for this binomial random variable x is given by this formula. So what is the probability that capital X is a random variable and small x is a number, is a value of that random variable. It can be 0. You see, your small x can go from 0 to n. You see, because we have n Bernoulli trials, so how many successes I can get? I can get either 0 success or at the most n successes. I cannot have more than n successes, right? In every trial I got a success, so at the most I have n successes. So this is the formula. NCX, this is the combination NCX, right? P to the power x, because we have x successes. So P is multiplying x times P into P into P up to x times. And there are remaining n minus x are the failures. So failure is 1 minus P. If P is success, then 1 minus P is failure. So this is the formula which you have to remember to write the binomial probabilities. Alright. So this random variable x is called binomial random variable and is said to have a binomial distribution with parameters n and p. So whenever you say that I am concerned with a binomial distribution, the next question is, okay, then what is your n and p? Because whenever you say binomial distribution, n and p are associated with it. That how many trials you are considering, that is n, and what is the probability of success in one trial, that is p. So if your n and p are given to you, then it is well known. Now you can say that x is also not known here. No, x is a question. X will be given as a probability question. Let's say if x is 1, you will put 1 here. If x is 2, you will put 2 here. So for any x from 0 to n, I can find the probabilities. Alright, so this is your binomial distribution. So now there are some assumptions and some steps involved in binomial formula. You remember these steps and these assumptions, you can easily solve this binomial question. So what is the first assumption? There are n trials. As I discussed before, you need n trials. Every trial has 2 outcomes, success and failure. Okay. The trials are independent. This is another assumption. Your one trial should not depend on the other trial, or the next trial should not be depending on the previous trial. Otherwise, your probability of success will change in each trial. If your trials are independent, the probability of success will remain the same in each trial. That is P. Okay, so this independency is very important. The success probability P remains the same. It automatically will remain the same when your trials are independent. All right. So these are 4 assumptions which are very important. These 4 assumptions. All right. If these 4 assumptions are fulfilled, it means we are having a binomial distribution question. Then how to write the formula? I need to go through these 4 steps. Step 1 is identify a success. What does it mean? It means figure out what does a success means. Maybe in literal meanings, a failure is your success. Okay. For example, you are not interested in heads, you are interested in tails. Usually tail is not considered as a success, but if you are interested in tails, then tail is your success. All right. So determine P. This is the next step. Once you identify a success, it will be very easy to determine P, right? The success probability. Third thing is determine the number of trials and how many trials you are having. Okay. And then after getting these 3 things, you can easily write the formula. We know this is the usual formula. Once you got NP, you can write the formula easily. So let's look at the example. Let me I'll come back to this cumulative probability. We did this in previous lectures. What is the CPF, right? Cumulative probability distribution function, but I'm not interested in that. Let's say this is the shape of a binomial distribution. What is the shape of binomial distribution? Shape of a binomial distribution depends on your P. Okay, if your P is equal to 1/2, 0.5, you know the probability of success can be 0 or can be 1 or in between, right? So If it is exactly in between, that is p is equal to 1/2, then your binomial distribution will be symmetric. Okay, symmetric means it will look like the same from both sides. You see, the left side and the right side is exactly the same. If your p is less than 0.5, then it will have a right tail, so positively skewed. You see, right skewed. So if you have this thing, you have right skewed, and if you have greater than 0.5, it will be left skewed. Okay, so you have a left tail here. You see, there is a left tail here, and here it is a right tail, right? A little bit tail on the right, but here no tails, exactly symmetric. So your shape of the binomial distribution will depend on the probability of success p. If n and p are your parameters of a binomial distribution, then mean of a binomial distribution is np. Every time if you calculate the mean, it is np. Okay, and if you calculate the variance, it is np into 1 minus p. But once you take the square root, then you have to take the then it will become the standard deviation. So this inside thing is a variance, but with a square root, this is your sigma, which is a standard deviation. So if n and p are given to you, then the product np is your mean, and product np 1 minus p square root is your standard deviation. You can verify this as well. Let's do this example. According to the daily racing form, the probability is about 0.67 that the favorite in a horse race will finish in a money. What does that mean? Will finish in a money means he will get either first position, second position, or third position. That's what we mean. Otherwise, you will not get money, right? Because usually the prize money is only for first 3 places. So either first, second, third place, you will get a money, right? So that's what they mean, that a one typical horse will end up in a money means he will get first, second, or third position. The probability is 0.67. In next 5 races, you see, in next 5 races, it means these are the number of trials. I am considering 5 races. You see, in one race, this is the probability. In one race, I am considering 5 races, so this is your n. What is the probability that the favorite horse finishes in the money? So it means I am also interested in the same thing which was given to me. The probability was given for ending in a money, and I am also ending in a money. So it means this is the probability of p. This is the probability p is given. I did not say that this is p at the beginning. Why? I don't know. I'm interested in this or not. So this is my p and this is my n. Okay. So see, he said identify a success. So I identified success. My success is if I get first 3 positions. Then he said, okay, find p. This p is given to me. This is the probability that he will finish in a money. So this is my p. And then third step is determine the number of trials. So I determined the number of trials n. Okay, now I can answer you anything. Now I can write the binomial formula and answer you anything. So he asks you, what is the probability that out of 5 races, exactly 2 times you end in a money, you finish your race in a money, exactly 4 times you finish your race in a money, and at least 4 times. So these are 3 questions. Okay, then D part between 2 and 4 times. So one by one I can answer. Okay. Now what is your random variable x? Of course, x is the number of races finished in money, because you are interested in finishing in money. So I am saying that let x be a random variable that represents the number of races finished in a money. How many total races are there? 5 total races. So I can end in a money for 0 times, means I never end up first 3 positions, or 1 times I win the race, or maybe 2 times, 3 times, 4 times, at the most 5 times. Okay, so this x can go from 0 to 5. Now number of trials is n, p is 6, 7. So I can write this binomial formula very easily. Now I will replace only n. You see, this is my n, this is my p 0.67, and this is my 1 minus p, and n is also 5. You see, these things are given to me, so I replaced in the formula. But my x is x. I did not replace anything for x. X is x. Why? Because here x is not known to me. Whatever you x give me, I will give you the answer. So now the question was, what is the probability that you end in a money exactly twice? Exactly twice means your x is equal to 2. So this is what you are looking for. The probability that x is equal to 2. Now I will replace this value here. If I replace x is equal to 2 here, you see, if I replace x2 here, it means I will replace x2 here, I will replace x2 here, and 2 here. Alright, so I got these three things. So you can look at this formula. This becomes 5c2, 0.67 to the power 2, 0.33 to the power 5 minus 2, which is 3. Now you can use calculator or the formula. You don't need to use this formula. Okay, so you can just use calculator. 5c2. In your calculator, it's written n. It's difficult to write with the mouse, but let me try. NCR. This will be written in your calculator. So what you have to do, you will press 5, then press this button, and then 2. So it will give you 5c2. Alright, so after getting 5c2, 5c2 is 10. This is 0.67 square, and this is 0.36 cube. And the answer is this one. So out of 5 races, you will end up winning 2 races, is this 0.162. Now the question is, what is the probability that you finish in money exactly 4 times? Exactly 4 times means x is equal to 4. So if x is equal to 4, now you replace x is equal to 4 in the formula. You see, power x and power n minus x. So I just replace here, you see, you had 2, x2, x2. Now I replace this x by 4, and you can simplify. Your answer is 0.33. Then C part was at least 4 times. What does that mean? At least 4 times means x greater than equal to 4. Either 4 times or 5 times. At least 4, right? 4 or 5. So 4 or 5 means 4 plus 5. You added the probability of 4 winnings and 5 winnings. Okay. So now you see, this is with 4, x4, then x5. So this x5. So in the formula, we replaced x by 4, then replaced x by 5, and now we are adding these two probabilities. So this is 0.468. Then the D part was, what is the probability between 2 and 4 inclusive? You see, between 2 and 4 inclusive. So from 2 to 4. So there are 2 ways. What you can do, you can so here it's what I did, you see, it's not necessary. What you can do is, you see, I have from 0 to 5, right? So this is your 5 and this is your 0. Okay, so now he said between 2 and 4. Between 2 and 4. This one. So instead of doing this one, we calculated probability from 0 to 4. Sorry, the other windows opened. So I'm looking for probability 0 to 4. Let me pick this one. So from 0 to 4. And if I subtract, let's say from 0 to 2, if I subtract this probability, right, so what will be left? The probability which will be left will be, let me use other color, so it will be from 2 to 4, right? 2 to 4. So that's the idea, they used it here. So calculated 0 to 4 and subtracted 0 to 2, so you got 2 to 4. So probability of x less than 4 minus probability x less than 2, you can find that. But of course it will be log. So what you can do is, between 2 and 4, there is just 2 add 3 here, you see. So you can find the probability of 2, 3 and 4 and add them up. Okay, that will be correct as well. You can find the probability with 2, 3, 4. You can add, you will get exactly the same answer. Okay. So the last thing was, what is the mean and standard deviation of the random variable x? And you know that the mean and standard deviation of x is np. Your mean is np, so I just multiplied. N is 5, p is 0.67, so you got np this. Okay, and npq is as np into 1 minus p gives you the variance, right? So if you replace np 1 minus p, multiply, take the square root, this is your standard deviation. So finding mean and standard deviation is very, very easy because we know the formulas. This is another example. It's solved example. You can go through it. Very easy. I'm leaving this example for you. There are 5 questions given here. 1, 2, 3, 4 questions. Okay, so these are all binomial questions. Okay, and you can also do that as well. Let me go through one of the example. I'll give you np and then you can write the formula and answer. For example, this question: in testing a certain kind of truck tire over rugged terrain, it is found that 25% of the truck fail to complete the test run without a blowout. Okay, so out of next 15 trucks tested, find the probability that 3 to 6 have blowouts. You see, now the question is about blowouts, right? The question is about blowouts. So it means I'm interested in blowouts. So what is the probability of blowout? You see, it is found that 25% of the trucks fail to complete the test without a blowout. Without a blowout. Okay, so it means they have a blowout because they fail. Because they fail to complete the test without blowout. It means 25% of the trucks have blowout in their test. Okay, so this is my P. So this is my P, 25%. It means P is 0.25. 25% means 0. Sorry, it's difficult to handle mouse. Let me try again. Zero 0.25. Okay, this is my P, and how many tests? N. So this is my N. This is my N. Because of the next 15 trucks tested. So your N is 15, sorry. Okay, so N15, P 0.25, and that's it. That's what you need for binomial distribution. So you can easily write the binomial distribution now as NCX. So N is 15. So you can write 15CX, P to the power X, and N minus P to the power 15 minus X. So your probability for let me see, the probability of X equal to small x is equal to, sorry for this type of writing, 15 CX P to the power X, which is 0.25, and 1 minus P, which is 0.75 to the power 15 minus X. Okay, very, very bad writing, but let's pardon, it's difficult to write with the formula. anyway with the mouse, sorry. Okay, so now you can answer anything. So what is the first question? First question is, what is the probability that you have from 3 to 6 blowouts? It means probability from 3 plus 4 plus 5 plus 6. Okay, so you will write similar to this one, like here. Where was this example? This one, right? So you like this 4 plus 5. Over there it is from 3 to 6. So you will write x equal to 3, x equal to 4, x equal to 5, x equal to 6. So 4 times you will use the formula and write your answer. Fewer than 4. Fewer means less. Fewer means less. So fewer than 4 means x less than 4. Okay, this is what we mean by fewer than 4. And then more than 5. More than 5 means x greater than 5. So you want the probability of x greater than 5. So less than 4 means 0, 1, 2, 3. 4 is not included because less than 4. 4 is not included. So 0, 1, 2, 3. And more than 5 means 6, 7, 8, 9, 10, up to 15. Up to 15. You can make it short because you know that sum of all probability is 1, right? So if I subtract 1 minus, you can reverse the inequality. You can write x less than 5. Why I did this? Because if I find the probability of less than 5 means 0, 1, 2, 3, 4. Only 0, 1, 2, 3, 4. So 5 formulas. But if you go from 6 to 15, there are 10 formulas, right? 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 10 formulas. So it's better to go to the other side because let me write it here. You see, you are going from 0 to 15. 0 to 15 and you are here. More than 5. So you want this probabilities. So instead of this, you found this other probability, right? This one. This is x less than 5 probability. This is x greater than 5 probability. But x less than or equal to 5 because 5 is not included here. This is x greater than 5, right? So when you write the opposite, it will be x less than or equal to 5 because 5 is not included over there. So you have to include it here. So you will find the probability of 0, 1, 2, 3, 4, 5. 6 probability, these probabilities, all of them. Now you know that total probability is 1. From 0 to 15, probability is 1. So if you subtract this probability from the total probability, you will get this probability. Okay, so you can do x greater than 5 as 1 minus probability of x less than or equal to 5. Why I did this one? Because this is easy to find. There are only 6 probabilities here from 0, 1, 2, 3, 4, 5. And if you start from here, 6, 7, 8, 9, 10, 11, 12, up to 15. Too many things to do, right? So it's better to find this probability and subtract from 1. You will get this probability. All right. So try to do these problems. They are easy. Again, if you have any questions when you solve these questions, and if you have anything, just send me the picture of your solution and I will see where you are doing the mistake or anything. Okay, so try to go through this as soon as possible and give me your feedback, and also ask me questions if any. Next is the multinomial distribution. Multinomial distribution is little general than binomial. It's easy. You see, in binomial you had only 2 outcomes. We call it binomial. Now you have multinomial. It means it's more than 2. We call multi, right? More than 2 outcomes. So if your given trial can result in k outcomes, not in 2. It can be in 3, 5, 10, 15, 20, whatever, right? So k is any number which is greater than 2. If k is 2, then it is binomial. Now, if there are k outcomes and every outcome has a probability as well, p1 up to pk, then the probability distribution of the random variables x1 up to xk, representing the number of occurrences of e1 up to ek, total number of trials are still n, is given by this. This is how we write it. that this is x1 x2 up to xk. This is the question, right? P1 P2 up to pk is the probability of k successes, and n is total number of trials. So this is nc x1 x2 up to xk, p1 to the power x1, p2 to the power x2, pk to the power xk. Okay, this is the multinomial distribution. And you know that what is n? This is the permutation of like terms. You remember the formula? Permutation of like terms. So always remember, sum of all these probabilities will be 1. These probabilities, the sum will be 1. And if you add these, what the question is, if you add x1 up to xk, it's exactly equal to n, number of trials. All right. So this is these are the two assumptions here. So for example, here he said the complexity of arrivals of and departures of the plane at an airport is such that the computer simulation is often used to model the ideal conditions. So for a certain airport, I don't know what airport is that, but any airport with 3 runways, you know that airports have runways and more than one runways. So let's say it has 3 runways. It is known that the ideal setting, the following are the probabilities that the individual runways are accessed by randomly arriving commercial jets. So if any of the any of the runway can be accessed by a plane, is this. The probability is 2 by 9, runway 2 has probability 1 by 6, and runway 3 has probability 11 by 18. These probabilities are given to us. Okay. He said, what is the probability that 6 randomly arriving airplanes, so see, this is my n now, we considered 6, right? So this is my n. What is the probability? He said, what is the probability that 2 airplanes uses runway 1, 1 airplane use runway 2, and 3 airplanes use runway 3. Now you see, 3 plus 1 4 plus 2 6. So if these are my x1, x2, x3. Small x1, this is my x1, this is x2, this is x3. So if you add x1, x2, x3, it's exactly equal to n. And if you add p1, p2, p3, it will be exactly equal to 1. All right. So now if my random variable x1 represents runway 1, x2 represents runway 2, and x3 represents runway 3. So you see, let x1, x2, x3 represent the number of arrivals at runway 1, runway 2, and runway 3 respectively. Then using the multinomial distribution, I can answer you this. Basically, they ask me what is the probability of 2 uses runway 1, 1 uses runway 2, and 3 uses runway 3. Now these are the probabilities of runway 1, runway 2, runway 3, P1, P2, P3, and total number of trials are 6. So what is the question? 6c x1, x2, x3, p1 to the power x1, p2 to the power x2, and p3 to the power x3. Okay, so what is the permutation of like terms? We take the factorial of n, this is n factorial, divided by x1 factorial, x2 factorial, x3 factorial. Calculator will not give you this. There is no button in calculator for permutation of like terms. So you will remember this, n in the numerator and 2, 1, 3, x1, x2, x3 in the denominator with factorials. Okay, now if you simplify, this is your probability. So this is the probability that out of 6 airplanes, 2 will use runway 1, 1 will use runway 2, and 3 airplanes will use runway 3. Okay, so these are some questions for multinomial distribution, these 3 of them. Okay, so try to solve these 3 multinomial problems and these 1, 2, 3, 4 binomial problems. Okay, so try to solve them as soon as possible and figure out if you have any concerns, any question, anything. Just send me the question in WhatsApp group. If you are solving on a paper, take the picture of the question where you are having difficulty, send me in the group. I will try to explain more. Okay, all right guys, good luck with this binomial and multinomial distributions. I hope you are staying home, not going out unnecessarily. I hope this disease will go away soon and we will resume our classes. Until then, stay home, stay safe. See you in next video. Assalamu alaikum. Have a nice time.